Now that we've talked about reaction rate, it makes sense to go ahead and talk about equilibrium, which is really one of the most important topics in chemistry. And the reason that reaction rates relates to equilibrium is because equilibrium is defined when the forward rate of a reaction equals the reverse rate of a reaction. And we'll see how that plays out. Chemical equilibrium is different than the type of equilibrium that you would discuss in physics. In physics, you're looking at balanced forces and no net movement. In chemical equilibrium, there's constant movement between reactants and products. However, the relative amounts of the reactants and products stay the same, but the reaction is constantly going back and forth. Another way to describe this is to say that equilibrium is macroscopically static. That means, from the larger scale viewpoint. But if you were to look at it on the molecular level, then you would see that the reaction is still taking place. It's helpful to think about equilibrium in terms of the change of concentration and to look at this graphically. So if we take a graph of this reaction, so this is nitrogen reacting with hydrogen to produce ammonia. This is known as the Haber reaction. So initially we start off and we have no ammonia, this is the red line, and we have a certain amount of nitrogen and basically 3 times that amount of hydrogen. So over time, the reactants decrease in concentration while the concentration of the product, which is ammonia, increases until they reach a constant value. And at that point, equilibrium has been reached. As I mentioned previously, this is also the point at which the rate of the forward reaction equals the rate of the reverse reaction, so that there's no net change. This point can also be illustrated by looking at a graph of the rate of the forward reaction and then the reverse reaction. So in the beginning, the forward rate is very fast, and then it gradually slows down until it reaches a constant value. At the same time, the reverse rate starts off at 0 and increases until it equals the rate of the forward reaction. So here we have a reaction between water vapor and carbon monoxide to produce hydrogen gas and carbon dioxide. And the question is, so let's say that we're at equilibrium and we add more of the H2O. So essentially what we've done is we will have upset equilibrium. So some of the H2O will have to react. So it will initially go up because we've added something, but it will go back down a little bit. In order for some of the water to react, the carbon monoxide will have to decrease, and consequently the hydrogen and the CO2 will have to increase some. So this one is increase, then decrease, but still it's going to be more than the original amount. This one's going to decrease from its original amount or concentration, and these two will both increase. On the other hand, if we add something to the product side, what's going to happen is the hydrogen will go up because we've added something, and then it will go down, but it's still going to be more than it was originally. In order for some of the hydrogen to react, some of the carbon dioxide will react, and we will have more carbon monoxide and H2O gas.